Welcome everyone. In this video, we are going to learn about the classification of number. This is the learning outcome for this subtopic. When we first learn to count, we use the numbers 1, 2, 3 and so on. These counting numbers form natural numbers and denoted as n. The set of natural numbers contain the prime numbers, which is denoted as p. Prime numbers are natural numbers that can only be divided by itself and 1. From the example given, we notice that 1 is not a prime number and 2 is the only even prime number. As we gain deeper understanding of numbers, we add the number 0, which then form the set of whole numbers and denoted as w. So, instead of starting with number 1, whole numbers start with 0. Thus, the natural numbers are subset of the whole numbers. We can also add negative values of the natural numbers, expanding our view to integers, which is denoted as z. In fact, the natural numbers are also called as positive integers and denoted as z plus. So, the integers are actually include the whole numbers and the negative of natural numbers. Thus, the whole numbers are subset of the integers. Between any two successive integers are the decimal numbers. These decimal numbers divided into rational numbers and irrational numbers. Rational numbers are numbers that can be represented as a fraction a over b, where a and b are both integers and b is not equals to 0. For example, negative 5 over 4 and 2 over 3. In decimal form, a rational number can be expressed as terminating decimal or repeating decimal. The number 5.27 with bar above the number 27 means that 27 repeats until infinity. And this number can be expressed as a fraction 58 over 11. 0.555 with 3 dots also can be expressed as a fraction 5 over 9. Rational numbers can be either positive or negative. The positive rational numbers are denoted as q plus. All of the integers are also part of rational numbers. Thus, integers are subset of rational numbers. Irrational numbers, on the other hand, cannot be expressed as fraction. Irrational numbers in decimal form are non-repeating and non-terminating decimal, such as third number like square root of 2, and third root of 7, logarithm, and constants pi and exponent 1. As you can see from the examples, the numbers after the decimal point are non-repeating and non-terminating. However, not all logarithms are irrational numbers. Some can be expressed as rational numbers too. For example, log 10, which is equals to 1. And same goes to third. Some thirds can be expressed as rational number. For example, square root of 9, which is equals to 3. Rational numbers and irrational numbers are mutually exclusive, which means they have no intersection between each other, and you can see it clearly from the diagram. The set of rational numbers and the set of irrational numbers form the set of real numbers. This means that the set of real numbers is a larger set consists of the rational numbers and irrational numbers. The relationship of number set can be shown by using the Venn diagram. From this diagram, we can conclude that natural numbers are subset of whole numbers are subset of integers, and integers are subset of rational numbers, and the union of rational numbers and irrational numbers equals to real numbers. The relationship of number sets can also be shown by using the structure diagram. the real numbers divided into two classes, which are the rational numbers and irrational numbers. The rational numbers will further divide into integers and non-integer ratios of integers. And if you still remember, integers consist of the whole numbers and the negative of natural numbers. The whole numbers itself are the natural numbers and 0. And the natural numbers are divided into prime numbers and non-prime numbers. Please submit this exercise to your lecturer before the class ended. Thank you for your attention. Have a good day.